Right, so what we're looking at here is a sample calculation for EDTA. So determining our amount of hardness in water. So a sample of water was analysed in order to determine the total hardness in the water. 50 centimetres cubed of my water sample. So that's my calcium ions here. Remember, hardness is caused by calcium ions. And some buffer solution in a rheochrome black tea. The solution was titrated, and this is my EDTA ion here. So 0.01 molar, and my average titration figure was 15.2 centimetres cubed. And I'm asked to calculate the total amount of hardness in water. Now, when we look at hardness in water, we look at ppm, so I'll get to that at a later stage. So this is page 306. I start off here, so I have 0.01 molar, which means moles per litre, which is 1,000 centimetres cubed. I don't have 1,000 centimetres in this question, I only have 15.2. So I multiply by what I know, 0.01 by 15.2 divided by 1,000, and that gives me 1.52 by 10 to the minus 4 moles. Okay, that's my number of moles in my solution of EDTA. So next I set up my ratio. And my ratio here is 1:1, okay, 1 EDTA ion for 1 Ca2 plus. So that means it's 1.52 by 10 to the minus 4. So I have the same number here of my hard water sample. Okay, that 1.52 by 10 to the minus 4 moles is what's in 50 centimetres cubed. And I need to find out here moles per litre, which is in 1,000 centimetres cubed. So again, multiply by what I know, 1,000, divide by the bit left over, 50, 3.04 by 10 to the minus 3 moles. So that is my answer in moles per litre, okay. And next then I'm going to find out my grams per litre. So I use my number of moles formula, equals mass in grams divided by my relative molecular mass. And hardness in water is always expressed in terms of calcium carbonate, always. You would be told that in the question. Obviously we're not told here, okay? And that gives you 100. So I have 3.04 by 10 to the minus 3 multiplied by 100. And that gives me 0.340 grams per litre. The final thing then, and you'll always be expressing all these hardness and water concentrations, and actually really anything to do with water, in ppm. And ppm is milligrams per litre. ppm actually stands for parts per million. Okay, and where that actually comes from is that milligrams, I have 1,000 grams in a milligram, and I have 1,000 centimetres cubed in a litre. So that's a million, so that's why it's called parts per million. So I have this in grams, I need it in milligrams, and there's 1,000 milligrams in a gram. So to find it in ppm, I simply multiply my answer by 1,000, and that gives me 304 ppm. So for this, you will always really be finding any of these concentrations in ppm.